Good day, ladies and gentlemen. You are highly welcome to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you, if you kindly subscribe to my YouTube channel, click on the subscribe button, hit on the bell to get the notifications of my videos anytime I upload. So now, this will be the continuation of the last video I dropped on formation of ordinary differential equation. So, which from the first problem we solved, we tried to solve or to form a differential equation with ordinary equation of one arbitrary constant. But today, so we'll be looking at one with two arbitrary constants. If you look at this equation up here, we can see that we have a and b. So where a and b are arbitrary constants. So now, and as I said from the first video, I told you that if you have two arbitrary constants, so you are going to arrive at the differential equation of order 2. So now, let's try to solve this. So now, having this, we have y to be equals to a cos x plus b sine x. So now, we try to differentiate this one with respect to x. So we don't need, this one is not implicit here because we have y separately. So the only thing we need to do, we have to find this, to get this one, find the derivative of this one, that is dy dx will be dx cos x plus d gs. Okay, we have a here, we have b sine x. So now, according to this one, we can see a is constant, so a will come back. Then we have a d dx cos x plus b is constant. So b is constant, so we have b d ds sine x. So now, what's the next thing? The next thing to do here is to get the derivative of this. The derivative of cos x is what is minus sine x. So therefore we have minus a sine x. Then the derivative of sine x is what is cos x. We have what? We have b cos what? Cos x. Then that is dy dx, dy dx. So now from here, so what's the next thing to do? The next thing to do is to get the second derivative of this. Okay, let me say this one is what? 1. This one is what? Is 2. So now we get the second derivative of this. To get the second derivative of this, this will be d square d2i over ds square. We give us what? We give. Therefore, we are trying to differentiate this one. We have minus a d dx of what? Of sine x, then plus b d dx of what? Of cos x. So now the reason why I'm bringing the constant out, because derivative of constant, so this one is just in what we can't take the derivative of this constant here, understand? So we bring it back. So that's why we left inside this bracket to be function of x ordinarily. So from here, so we have what? We have d square y s square to be equals to minus a. Now the derivative of sine x gives what? Gives cos x. Then the derivative of this one gives us what? Minus sine x. Therefore we have minus b sine x. So now from here, so what's the next thing to do? You can see that we have minus a, we have minus a. Definitely the minus can be factorized, so we have d square y ds square to be equals to minus a cos s plus b sine x. So now, so let's say this is what? This is equation 3. So if this is equation 3, we can see that there are some things that we need to take notes. So from here you can see that this equation 3 kindly resemble our given function, which is what, y. So therefore we employ 1 in equation 3 because our intention is to eliminate a and b. Understand? So we have d square y ds squared to be equals to minus, that is a cos x plus b sin x is same thing as what we have here, which is 1. So we have this. So now that is the solution to the problem. This also can be written as d square y ds squared. Try to bring this to the left hand side. We have plus y equals to 0, or you can still be written as y prime prime plus y equals to 0. So which is the solution to our problem. You can see that we have already eliminated a and b. Are you getting? And the reason why we take the second derivative of this, I told you at the beginning of the class that if you have two arbitrary constants, so you are going to have second order differential equation, and at the same time if you have 3, so you have to differentiate 3 times, understand, so that you have third order differential equation. So if you have any question to ask, kindly hit on the comment box to ask, and I'm here to give you to respond to your request. So you have a wonderful day.